Okay, look, this is a nice question, I must say. I don't know, there's something cool about it. I didn't set it, so I can say that. The path of the ball dropped from a height. So you can imagine somebody throwing this ball and going, along and going, dong, 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 yes, with those sound effects. Okay, so it says the first parabola has that equation. So imagine that this first parabola, you were just given this first parabola. So I'm going to draw it in like that, and it went down there, and you were told, oh, there's a point, there's point A. We know something about that point. What's special about it? And we're given that the equation of that one is h of t equals minus t squared plus 16. Okay, so we know how to work out what the coordinates of A are. That's easy enough to do, right? If you're just given this red parabola. And in fact, you could find out what this coordinate is as well. So I assume that's going to be B. So it's easy enough to find out B if you were just given this parabola minus t squared plus 16. You could work out A and B. In fact, you could have done that last year. It doesn't even relate to what we're doing this year. But then the questions are going to get more interesting. I'm going to say, okay, so find out that this height. Well, that's easy. So the first question is asking, what is this distance here? Well, if you've got A, then that's going to be easy enough. So this relates to question A. Write down the number of seconds. Well, if we labeled our axes, this would be a whole lot nicer. And we said, this is t, time, and this bit here is our height, h. Therefore, if we're asking for how many seconds, aren't we just saying, what is this distance over here? So that's how you're going to find out question B, and that relates to point B as it so happens. And then after each bounce, the ball rises to half the height. Okay, well, we know what this height is here, so it isn't going to be easy enough to go, well, this bit here, its coordinates, we don't know what its x value is necessarily, but we do know that that height is going to be half that big height. So I don't know what this height up here is. I'm going to leave it to you to find out. But if we know what it is, we know this bit here is just going to be half of that height up there. I'm not going to say half A because it's not half the point, the coordinates. So use this information to find the equation of the parabola DEF. This one here, DEF. Okay, so I'm not going to give everything away here, but we've got an idea of what that point will be. We know that this full distance, kind of the x value, will be halfway along, and we're going to just keep using that logic along and along and along. So for this parabola here, let's do it in a bluey color and say this parabola here, we're trying to find its equation. So we're going to need its turning point, definitely. Now, the y value of that turning point is going to be pudsticks to find, right? We also know that this thing's shrinking down by half, so that's going to be kind of half the size. This is going to be half the size of that one. We know that these are the x-intercepts, so we know the y values are 0, and we know what that is. We can find the other one, so we can find that. Now, it is a 5-mark question in the end of the test, so it's meant to be a bit more challenging, but I think you've got it in you, and hopefully these scribbles haven't become too scribbly, if you know what I mean. Where it was the big parabola, then you know how to find this one because that's half. So you know what that is. You know what this value here is. You can work out what's happening with these intercepts here, and you can go from there. And I think there's one more question. A certain parabola in the sequence has x-intercepts exactly half a second apart. Write down the coordinates of the turning point. Okay, so what it's asking is it's saying one of these parabolas is going to look like that. It's x-intercepts. So if we drew, just interested in the x-axis, which I've called the t-axis, it's saying that this distance between is going to be, I'm just going to scroll down and double check. It says that they're exactly half a second apart. So the x-intercepts, so this distance is going to be a half. Therefore, what's the turning point? I'll leave it to you. That's at least a sort of a bit of an end to the question to see what it's asking. Okay, not sure again. Let me know. I don't know if the video is helpful. I think it's nice to kind of give it, instead of just seeing this all the scribbles, you can see them develop. Let me add some text in here so that might be helpful as well. And keep at it, Luke. Love it.